In this video, I'm on page 1150. This is video 22-2B. We're going to be talking about how we determine if events are independent. And remember from the last video, we're talking about that means one probability does not affect the other. Okay? We're going to work through some numbers here to talk about whether that's true or not. So the probabilities that we're checking is whether the conditional probability is the same as its basically probability without the condition. So in example 1, we have, and I'm going to highlight that because that's an important piece for you guys to keep in mind, is the conditional probability of A given something has happened equal to the probability of A alone. So, all right, in example 1, we have a two-way frequency table here that is giving us some information about some flights that are arriving at an airport. The flights are in the two-way frequency table because they either qualify as late or on time, or domestic or international. So what we're exploring here is in event A here, or in part A of Explain 1, we want to know, is the event that a flight is on time independent of the event that a flight is domestic? So we're letting O be the event that a flight is on time, and let D be the event that a flight is domestic. So first off, we're going to find the probability that it is on time just in general. Well, all of our on-time flights are 162 total, and divided by the total number of flights of 180. So our probability is 162 out of 180, or 90%. Then we're going to find a subspace is given that it's a domestic flight, is it the same probability for it being on time? So in that case, given that it's a domestic flight, okay, looking only at the top row of our two-way table, there are 120 total domestic flights, and of those flights, there are 108 of them that are on time. So the probability of on time given domestic is 108 divided by 120, or also 90%. So what we just determined is, since the probability of on time given domestic is the same as the overall probability of just on time, then the event that a flight is on time is what we would say independent of the event that a flight is domestic, meaning it being a domestic flight does not change the probability of it being on time. Let's look at part B. Part B says, is the event that a flight is international independent of the event that a flight arrives late? So for labeling distinction, we're letting I be the event that a flight is international, and L be the event that a flight arrives late. So we first, of course, need to find the independent probability of just it being international. So the total of international flights in this case is 60 out of 180. So we have 60 international flights, so the probability is 60 out of 180, or 33% when we convert to a percent there. Then we want to find the second probability is the conditional probability, and given that it's a late flight, so that is this first column, is the internationalness of the flight going to be independent of it being late. So to find the probability of an international flight given that it's late, there are total flights that arrive late is 18, and of those flights, of that first column, there are 6 that are international. So the given probability, or the conditional probability of I given L, is 6 out of 18, which also comes out to 1/3, or 33%. So what we just figured out in part B is, since the conditional probability I given L is equal to the independent probability of I, then the event that a flight is international is, circle is there, independent of the event that a flight arrives late. So on the next page, I would like you guys to do the your turns here with a new two-way frequency table talking about whether a apartment is one bedroom or two or more bedrooms, and whether it is single occupant or multiple occupants. Excuse me. So please make sure that you take a look at numbers 3 and 4 here, the events that are given in those, and see what you guys can come up with, whether those events are independent or not. We'll see you guys in the next video.